Hello, myself Lal Singh Banjara. I'm assistant professor in Department of Chemistry in Girls Degree College, Sadol. So today I will discuss about hypervalent iodine and their synthetic path and their synthetic utility. So this is a brief outline of my talk, where I will first discuss introduction, what is hypervalent, then I will discuss different kind of hypervalent iodine. Then after that I will discuss about their different kind of organic transformations by using these hypervalent iodines, and then finally summarize my talk by acknowledging. So first, what is hypervalent iodine? So the concept of hypervalent iodine is established by J.J. Musar in 1969 for the molecules with elements of group 15 and 18 that breaks the octet rule and formally has more than 8 electrons in its valence shell. So main group elements species that exceed 8 electron in valence shell, typically these are two types for iodine, that is first in iodine third and second is iodine 5. So they are generally categorized based on their valence shell electrons. So species that accommodate up to 12 valence electrons, so these are generally Des-Martin per iodine, and another one is that is IVX, and another class is species with 10 valence electrons, and these are most common. As you see, the first one is PIDA, second one is PIPA, another one is that is Cossas reagent and Togli reagents. So these are the hypervalent iodine, those are commercially available. If we talk about the history of these molecules, so the both iodine third and fifth compounds were first prepared by Will Gerard in 1886 and 1900 respectively. The first one is dichloroiodobenzene and second one is iodyl benzene. So these molecules are represented by a specific term, that is lambda, and based on their coordinations, if the molecule is coordinated with three another molecule, three another molecules, so that is a lambda iodine 3 iodine, another one is lambda 5 iodines. Sometimes it is called as a periodines and periodinanes. So if we study in IUPAC, so the lambda is basically non-standard bonding. So it is a kind of non-standard bonding where the bond length of these bonds is generally higher than actually the bond which has a bond length. So our in mind first question comes, what is hypervalent iodine? So basically the chemical property of this hypervalent iodine is similar to the heavy metal agents such as mercury, tholium, titanium, lead, and they are generally less toxic and environmental issues. They are generally uh, prefer as a mild reaction conditions and easy to handle. Hypervalent compounds are readily reduced to stable non-valent site with the dissociation of apical groups, but they act as a good oxidizing agents. Commercial availability of key precursors makes very effective for the use of these molecules. So this is generally bonding nature of these molecules, where the first one is that is iodine containing. The geometry, if you see the iodine third has two kind of geometry. First one is tetrahedral and second one is pseudo trigonal bipyramidal, while iodine 5 is having pseudo trigonal bipyramidal as well as square pyramidal geometry. This is the synthetic path where we can prepare these hypervalent molecules. If you see the reactions, the first one I am here discussing about the oxygenation, where phenyliodazobenzene, this is the polymeric form, which is activated by the depolymerization by treating with alcohol and forms iodine third compounds. With the excess alcohol, generally it forms PHIOMe2, and that can also be generated from PIDA, phenyl iodized benzene. Another one is how can people iodine third reagents is a cyclic containing benzene containing hypervalent iodines.